For the past 2 years, I've been using NixOS on pretty much every Linux device that I own. Now, that in and of itself is not surprising. NixOS has recently become somewhat of a new Arch Linux, by the way. And if you go to any space with a high concentration of Linux geeks, you'll find that a large part of them runs NixOS on their laptops. But apart from running NixOS on my gaming PC, and also running Nix Darwin on my MacBook, I also run it on my main storage/media server. Yes, even though there are purpose-made operating systems out there that are made specifically for building a storage server, which all have fancy web UIs and large communities, I still chose the hard way, a general-purpose Linux distro with a command line interface. And not just any regular Linux distro, but one that's configured exclusively using an esoteric, domain-specific, functional programming language. One that's not known for its amazing documentation, but is known for its steep learning curve, and one whose community is a constant source of drama and conflict. Why did I do that? Well, it's not because I hate myself, even though it is a contributing factor, but the short answer is NixOS scratches that neurodivergent itch that I have to set my computer up just the way I want them. And it scratches it in a way that Ansible or other config management tools aren't quite able to. In some ways, the process of writing infrastructure code for my NixOS home lab is a big part of why I like it so much. It's kind of like building Lego, only with more stepping on small pieces. Now, if your home lab/home server is a practical tool that should just work, and you want to spend as little time as possible configuring it, NixOS is probably not for you. You'll be much happier with something like Unraid, TrueNAS, or maybe even an off-the-shelf NAS. But for the rest of you, for whom the home lab is not just a way to run your services, but also a playground and a place for experiments, well, maybe throughout this video, I'll be able to convince you to join the Church of Nix. In this video, I want to focus on my main home server in particular, and I'm going to start by telling you what I'm running on it, and then show you how I have it all configured using NixOS. Now I want to get one thing out of the way before we start. This video is not a tutorial, it's not a step-by-step guide on how to set up a NixOS-based home server. I'm just going to walk you through how I have things set up, and if you find some aspects of it useful or educational, that's great. But I'm definitely not qualified on teaching people about Nix. I do know someone that is qualified on teaching people about programming though, and that is the amazing people at Boot.dev, who's sponsoring today's video. Boot.dev is a gamified online learning platform that teaches you backend web development in a really cool RPG themed setting. Its authors believe that the biggest problem about learning how to program is boredom. So they've designed their learning platform with focus on hands-on coding lessons, tight feedback loops between learning a concept and applying it in practice, and packed their courses full of game elements like achievements and quests to make sure your gamer brain gets its dopamine hit. I've personally started learning Go with their course that is appropriately named Learn Go, and loved the way it makes you write code pretty much from the very beginning. Lane, the author of the course, is also great at explaining stuff, and is definitely one of the best online programming courses that I've tried. All of the content from Boot.dev is free to read and watch in the guest mode, but by signing up for a paid membership, you also unlock interactive features like hands-on coding, progress tracking, and game mechanics. So go ahead and try Boot.dev today. Check out the link in the description and use the code Wolfgang to get 25% off on your first year if you choose the annual plan. Additionally, one lucky person can get an entire year of Boot.dev for free using this coupon code. So thank you Boot.dev for sponsoring today's video, and now let's get back to our home lab. Let's start with what services I'm running on my current media server. First off, the homepage you're seeing is literally called Homepage. It looks great out of the box and has icons built in for most common self-hosted applications. It also supports widgets for some services. So for example, if you enable the Jellyfin widget, it will display the number of series or movies you have in a database, or if you enable the Deluge widget, it's going to display the number of torrents and the download speed. Personally, I don't use widgets. Most of the time, I don't find the information in them all that useful, and they also require you to either create an API key or a service account in the apps that you want to get the info from. And that's just more trouble than it's worth for me. The only widget I do have is Glances, which displays stuff like CPU temperature, memory load and stuff, but it's more for aesthetics than anything. I'm also using some custom CSS code just to make the page a bit prettier, in my opinion. I made it so that it uses the San Francisco fonts, the default font that Apple devices use, and there are also a few tweaks for margins, spacings, and so on. Right, so let's move on to the applications themselves, starting with the R stack. I'm not going to talk too much about it so that I don't anger the YouTube TOS gods, and I'm also not going to dwell too much on the moral aspects of sailing the 7 seas. If you know what those apps are for, you know. And if you don't, you can find a lot of information online. Now the next column is in the same vein, and it contains my downloader applications. Deluge, which is a torrent client, and SabNZBD, which is a Usenet client. Now I've actually been using Usenet for about a year now, and I would say that I prefer it to torrents. Even though there's a cost to entry, which for some people might defeat the purpose, you can find some pretty good deals on Usenet networks. A lot of the time they're lifetime deals or one-time payment, and honestly it's a lot less trouble than fiddling with different public torrent trackers or juggling like 5 streaming services at once. Once again, sorry for being purposefully vague, and feel free to use your favorite search engine to get further information. Both Deluge and SabNZBD integrate super well into the R stack. I basically never have to interact with the downloader applications directly, and most of the time, things just work. Our next column is media, and here I have Audiobookshelf, which contains way too many Stephen King books. Audiobookshelf, just like the name suggests, is an audiobook server, which has client apps for both Android and iOS. It's basically a self-hosted alternative to services like Audible, and so far it's been working pretty well for me. Next up we have Immich. It's a self-hosted photo gallery which has client apps for both Android and iOS, and it's basically a self-hosted replacement for services like iCloud Photos or Google Photos. I have it running both on my own home server for my own photos and on the home server that I've set up for my parents, and both of them run amazingly well. I've always been let down by client apps for syncing pictures. Somehow they could never sync reliably, which, since my parents live 500 kilometers away from me, would kind of be a bummer. But Immich kind of just works, both the servers and the clients, and that's why I use it. Next up we have Jellyfin, a service that needs no introduction. It's a free and open source media server, basically your own self-hosted Netflix with your own DRM-free movies and TV shows. Not much to explain here. I do have the Skip Intro plugin installed though, which basically analyzes the sound signature of your series and detects intros, and then shows you a button to skip the intro, basically like all the big streaming services these days. So if you don't have that installed, definitely take a look at it. Next up we have a vague column that I call services. If you have a better name for it, please let me know in the comments. The first service here is Microbin, and it's basically a self-hosted paste bin. I can put some text or a small file in here, and then share the link with anyone. It's pretty useful on Discord or maybe on Reddit, where it's kind of inconvenient to paste big chunks of text or code. And it also does automatic syntax highlighting. So if I paste Nix code here, it would automatically highlight all the functions, variables, and so on. The reason I chose Microbin in particular is because A, I wanted something that looks good, and B, something where I can restrict who gets to upload and remove the paste bins. And the way I implemented this is through Cloudflare access. I have basically restricted the subfolders that are used for paste bin management to authenticated users only, and then left the subfolders to read the paste bins open for everybody else. I did do some styling customization here as well, and that actually involved changing the way the Microbin package is built, which might sound intimidating, but NixOS makes it super easy. I'll talk more about this later on in the video. Moving on to Miniflux. Miniflux is a super minimalist RSS reader, which I mostly use to read Hacker News and Phoronix. I've recently switched to an e-ink based phone as my daily driver, the video is in the works, and Miniflux, with its super minimal design, is the perfect choice for e-ink screens. Now for those of you who prefer the dark side, don't worry, Miniflux also has a dark theme, and in general it just gets out of your way and lets you read your news in peace. Now Nextcloud is yet another service that doesn't need much introduction. It started off as a file sharing service akin to Dropbox or Google Drive, and over the years it evolved into a full-on office suite / calendar management tool / email client / password manager / ethical AI / photo gallery. You get the idea. Now personally, I only use it for occasional file sharing, and yes, it's kind of an overkill for that. At the same time, I have tried a lot of simpler and more lightweight services, and so far, Nextcloud has proved to be the most reliable. Next up is Paperless-ngx. Personally, I think it's one of the most useful services that you can self-host, especially if you live in Germany. You see, in Germany, every company in every public office wants to send you letters, not emails, physical paper letters. So I tried to digitalize every letter that I get and ingest it into Paperless. Paperless then runs optical character recognition on your scans and builds a fully searchable database of all your documents. Moreover, it can also ingest PDF attachments from your emails, automatically classify documents depending on the contents, and much more. Personally, I don't think I've even scratched the surface of all of the Paperless functionality. As for the scanning, I don't have a separate scanner, so I just use my phone and an app called QuickScan, which has a native Paperless integration. So far, it works pretty well, but if you have a backlog of documents that you need to scan, I would definitely recommend a separate scanner, preferably one with automatic paper feeding, like Brother ADW 1700W. Our next service is Uptime Kuma. This one is also pretty popular in the home lab space, and what it does is basically lets you monitor your applications, APIs, or websites, and send out notifications when they're down. It has integrations with pretty much every messaging service out there: Slack, Telegram, Discord, Pushover, Mattermost, you name it. As for the actual monitoring, it can be as simple as a smoke test, just checking if the application returns code 200, or you can, for instance, search for a keyword in the HTML output. Apart from that, Uptime Kuma can also do some more advanced checks: gRPC, JSON query, Docker container checks, and even things like Redis, PostgreSQL, and a Steam game server. I use it for pretty much all the services in my home lab, and I'm pretty happy with it so far. And the last service in the service category is Vaultwarden. Vaultwarden is a password manager, and if you know Bitwarden, it's basically an unofficial rewrite of the Bitwarden server implementation in Rust. It's a bit leaner than the official implementation since it doesn't require the Microsoft SQL server, and it's also a bit more transparent when it comes to the installation process. You don't need a special shell script, you don't need to register installation with Bitwarden, and it also provides some features that Bitwarden only enables for paid plans, like OTP codes, file attachments, and more options for two-factor authentication. You can also use the official Bitwarden client applications with this, which is also great. Now to the smart home section. I've actually scaled my home automation down a lot since the last What's on my home server video. It's still something that I would like to set up once I have my own place, but right now I live in a rental, and I kind of just gave up on the idea. I still run Home Assistant though, and I mostly use it for two things. One, measuring the power consumption of computer hardware, using smart plugs, in my case Shelly Plug S, and actually controlling one part of the house that you don't want to be smart: heating. You see, the building that I live in right now is new enough to use in-floor heating, but also not new enough to include room thermostats. So you can basically only control the temperature for the whole apartment. So what I did is I bought a smart retrofit kit from HomeMatic, which includes battery-powered thermostats that are usually controlled from this proprietary cloud-enabled hub. Not good. Instead of that, I'm using a HomeMatic USB dongle and a service called RaspberryMatic to control the thermostats from Home Assistant. And it also shows you data like battery life, temperature, floor heating actuation, and so on. And yes, even though it's called RaspberryMatic, it works on other types of computers as well. Obviously, I would rather just have regular old thermostats with no smarts, but it is what it is. Both services are running on my router/firewall machine, and not on my main storage/media server, and that's because those are kind of mission critical, and my home server sees a lot more tinkering, rebuilding, and optimizing than my router machine. Last but not least, we got the Miscellaneous category. Here we've got PyKVM, which I use to remotely control my main home server, Fritzbox, which leads to the web UI of my cable modem, and it also currently doesn't work because of some firewall shenanigans, which I'm too lazy to fix. And finally, a link to the Immich instance of my parents, so that I can easily troubleshoot it when I'm at their place. And so far, it's been so stable that I haven't needed it. But that's pretty much it for the services that I'm running. As you can see, I don't run all that many applications. A lot of people might say that my hardware is criminally underutilized, and that I could probably get away with a Raspberry Pi or an Intel NUC instead of an actual rack-mount PC. I mean, some of you guys use way less powerful computers to run multi-machine Proxmox cluster with dozens of VMs, game servers, Kubernetes clusters, and so on. And yes, most of the time, my storage server, which is based on an Intel i5-13500, is chilling at an average load of less than 0.20. But there's more to hardware than raw horsepower. My storage server has support for ECC memory, 8 SATA slots, QuickSync for hardware video transcoding, and all of that at an idle power consumption below 30 watts. Yes, the motherboard that makes all of that work is pretty much unobtainium. And yes, after Intel's recent snafu with 13th and 14th gen CPUs, I wouldn't recommend a 13th gen CPU to pretty much anyone, but it works pretty well for my needs, and I don't see myself switching to another setup anytime soon. As for fancy stuff like running a Proxmox or a Kubernetes cluster and running the services on multiple machines for high availability or redundancy, I think that's a great idea if you want to learn more about Kubernetes or hypervisors or just enjoy playing with that kind of stuff. But for practical reasons, in terms of a home server for one household, I prefer a simple setup with just 1 or 2 machines running all of your services with no fancy stuff like load balancing or high availability. Now for the part that you all have been waiting for. How is it all set up? Well, since the last What's on my home server video, I have switched from running Ubuntu server on my machines and setting it up with Ansible to then switching all of my Linux servers, including my VPS and my router/firewall, to NixOS. Now, those of you who have kind of heard about NixOS might know it as a Linux distro that lets you set up your whole system with just one configuration file. And yes, in its most simple form, you can in fact set up an entire home server with just one simple configuration file. Here, for example, I have a configuration.nix file that sets up a non-root user on your system, installs useful applications like NeoVim, htop, and rsync, and also sets up some typical home lab services like Jellyfin, Paperless, Immich, and after putting this file into /etc/nixOS on your machine and running NixOS rebuild switch, voila! We now have a home server setup that's already running some web applications. That was a lot faster than writing your own Ansible playbook, right? And that's because NixOS already does all the heavy lifting for you. Jellyfin, Paperless, Immich all have NixOS modules, which basically abstract all the process behind setting up a web application, like installing dependencies, setting up databases, creating users, folders, and permissions, behind a simple services.jellyfin.enable equals true. To go back to the Ansible analogy, it's as though Jeff Geerling already wrote a Jellyfin role for you, and all you had to do was just add it to your playbook. Now, some people might say that it's lazy, and that it abstracts a lot of knowledge about Linux, systemd, web servers, and deployments behind a simple config option. And if HomeLab for you is mostly about learning marketable skills for your IT career, then yes, in that case, maybe setting up something like an OpenShift cluster, learning Ansible, or even just raw dogging another general purpose Linux distro and setting everything up from scratch, maybe that would be a better move. But I am lazy and I already do all of that stuff in my day job, so NixOS it is. Besides, if you're worried that NixOS is going to be too easy, you see, one configuration file to rule them all is a nice concept in theory, but as your configuration grows, you'll find that this file gets harder and harder to parse. I mean, there's a reason why people split their code into multiple files, aside from simple shell scripts. Now, my Nix configuration includes code from my main home server, Emily, my router, Allison, my parents' NAS, Arya, my VPS, Spencer, my gaming machine, Maya, and finally, my MacBook, Meredith. These are all characters from Pretty Little Liars, by the way, in case you're wondering, so there's that. So one configuration file is definitely out of the question. Instead, I've decided to loosely organize my code into several components. Dots for personal user configuration, stuff like NeoVim, terminal configs, shell configs, basically stuff that you would usually configure in dot files. HomeLab, which includes configuration for services, networking, and file system mounts on my storage server. Machines, here I have machine-specific configuration for my hosts. Modules, which include non-HomeLab related app and service configurations. And finally, users, for user-specific configurations. There isn't really any standard or best practice on how to structure a NixOS configuration, and personally, I just took inspiration from some other people and just let my config evolve with time. Apart from that, I also have a secrets folder, which includes files with secrets, like passwords, API keys, and other credentials. I use HNix for secrets management, and there's also SOPsNix, which I think is a better option. Now, like I said, this video is not a NixOS HomeLab tutorial. The writer me is estimating it to already be about half an hour long. Let's see if the editor me agrees.
He does.
But I do want to mention a few cool/important things. First off, I don't use Docker nor Podman containers for any of my services apart from Home Assistant because, reasons, and HomeMatic CCU, because there isn't a NixOS module for it at the time of making this video. For the rest of the services on my machine, I use native NixOS modules, which means no containers. Most people use Docker to set up their home lab services, be that a simple Docker Compose file on a Debian server, or the Docker-based apps in Unraid or TrueNAS. So running applications natively is quite a departure.
But why?
Well, for starters, if you wanted to use Docker to run your apps on NixOS, you totally could, and you would still profit from the declarative configuration and other benefits of NixOS. But why do people even use Docker to run their self-hosted applications in the first place? Well, if we really get down to it, in home lab environments, Docker is mostly used as a package manager. It's got a huge repository of apps that you can run on any Linux distro, and there's no need to mess with PPAs, repository keys, and things like that. Docker also decouples the applications themselves from the system they're running on. So most of the time, no matter what distro, kernel, or systemd version you're running, you can run any version of a given Docker container with no issues. Docker also lets you consolidate the configurations for all of your applications in one place by using volume mounts. This makes it easier to do backups, and it also makes your configuration more portable, since you can just copy the configuration to another machine, point your volume mounts to it, and start your containers back up. So that begs the question, why go back to the basics? Why go from containers back to installing things natively on the OS? Well, on most operating systems, once you install, say, Jellyfin, you're on your own when it comes to the configuration. The locations for configs files themselves will also depend on the application. Some applications put it into /etc, some go for /var/opt, some others put stuff in /user/local/etc. It's a complete chaos. NixOS, on the other hand, not only has packages for pretty much every popular self-hosted application out there, but also often lets you configure them declaratively, something that Docker kind of provides with environment variables, but to a lesser extent. This makes it so that you don't need to back up your configurations because they're already declared in your code. But what about the application state, stuff like databases? Well, most of the time, NixOS puts the application state in /var/lib/application name, which makes it easier to back up. NixOS also includes easy-to-use services for database backups, and that's what I use on most of my systems. Basically, NixOS provides all the advantages of Docker containers, a large repository of apps and services, declarative configuration, and ease of backups, without some of the annoyances of Docker, like having to fiddle with permissions and volume mounts, having to mess with inter-container networking, port forwarding, and so on and so forth. At the same time, I am aware that containerizing your applications can theoretically decrease their attack surface, but containers are not a magic bullet, and a lot of people unknowingly use bad practices when running containers, such as running things as root, giving containers too many privileges, or mounting the whole Docker socket into the container. On NixOS, on the other hand, most applications run as their own users and also take advantage of systemd's hardening options, like private TMP, private devices, no new privileges, system call restrictions, and so on. So I wouldn't say that Docker or Podman containers have a clear edge over bare metal when it comes to security and attack surface. Personally, I chose to run my services bare metal and use the native NixOS modules. And what makes it possible in NixOS is 1. An amazing community which develops and maintains modules for all kinds of services, and 2. A unified configuration language which can be used for configuring the system itself, as well as all of the applications, services, and daemons running on it. But just like with any home lab service, it's often not enough to just configure and start the service itself. If you want a pretty domain name, instead of just using an IP address and a port, you're going to have to set up a reverse proxy. If you're using a home lab dashboard like homepage, you're going to want to add your application to it. And then there's also the service configuration, like port, host, user to run as, and so on. So for every home lab service that I'm using, I've written my own module on top of the module already provided by NixOS. Apart from just enabling the respective service, these modules also configure reverse proxy so that I can access my services using a pretty URL. They add the services to my homepage dashboard, and finally, they allow me to set sane defaults when it comes to configuring my services, and only expose the config options that are either machine specific or that I expect to change frequently, such as passwords, file mounts, network addresses, and so on. And this is what it would look like if you want to use this module on one of your machines. Another thing that I include in my modules are package customizations. For instance, in case of Jellyfin, in order to use the skip intro plugin, you have to patch the build script in order to inject the skip intro button into the web UI. Or in case of Microbin, I've also used a Nix packages overlay to apply a Nord color scheme to the code blocks and add support for Nix syntax. Okay, so the modules that I wrote kind of sound like roles in Ansible, and Ansible can also be used to configure your systems. So why not just keep using Ansible instead of learning an obscure functional programming language and an entirely new ecosystem around it? And here's the biggest reason for me. If you write this task in Ansible and run it on your system, it will install the packages. Run it again and look, nothing has changed, so our task is idempotent. But watch what happens when I remove a package from the list of packages to install and run the playbook again. As you can see, the playbook still runs with no changes. Why is that? Well, because Ansible doesn't take over the package management on your system exclusively. You can still install packages, update them, and change the configurations through other means, which introduces chaos. And yes, you can write a version of this task that would actually remove the packages once you've removed them from your Ansible code. Maybe it would look something like this. But that doesn't change the fact that Ansible is not a holistic solution, and using it as the only configuration tool in your system requires discipline and intent. Seeing how long it takes to run a somewhat useful Ansible playbook on your system, sometimes it's very tempting to just quickly install a tool in your target system to diagnose a problem, or to maybe quickly edit a configuration file to see if it works. And unless you're ready to force yourself to A, only use Ansible to change your configuration, and patiently wait for your playbooks to finish, or error out most of the time, and B, write all of your tasks in a way that disabling or removing things will also remove it on the target machine. Kind of like our example with the packages earlier. NixOS fixes all of that. Writing infrastructure code in Nix is, in 90% of the cases, the only way to configure your system. If you add a package to environment.system packages and then run NixOS rebuild switch, it will then get installed in the system. If you remove a package from that list and then run NixOS rebuild switch again, it will actually get removed on the system. There's no need to be intentional about writing your infrastructure code because NixOS is already built from the ground up to be declarative and reproducible. It's not your run-of-the-mill Linux distro with a package manager that doesn't have a stable command line interface that is then configured with a third-party orchestration tool that tries to work around its quirks. It's a complete, integrated, all-in-one solution. Applying the configuration is also blazing fast. With Ansible, things are executed task by task, and if a task fails, you're left with an inconsistent state. With NixOS, most of the time, if things fail, they fail fast, and they fail before the configuration gets applied to your system. That's one of the perks of a strongly typed language. Yes, you can also kind of do that in Ansible with argument specs, but it's pretty limited and you don't have to, whereas NixOS forces you to use types. Because of the fail fast approach, iterating on your configuration is also fast. The time frame between fucking around and finding out is a lot smaller. And if you do girl boss too close to the sun and make your system unbootable, every generation of your system is completely atomic and reproducible. You can simply boot into a previous generation by choosing it in your bootloader. And as for introducing manual, unrelated changes outside of your configuration management tool, well, most of the time, NixOS will actually not let you do stuff manually. Want to edit a systemd file? Hell no. Want to edit a configuration file? Nope, it's read-only. Want to install a package to quickly try it out? Well, yes, actually. NixOS includes a feature called Nix Shell, which is basically an ephemeral shell that includes certain packages which does not affect your main system. So, for example, if you want to run a tool like IOTop or FIO without installing it globally on your system, you can create an ephemeral shell with those packages and then exit it once they're done. This can also be used to create development environments for languages like Python, Go, or PHP without having to install all of your dependencies globally. Okay, I could talk all day about how NixOS is great, but let's face it, it's not all ponies and rainbows, and there are obviously areas in which Ansible or other configuration tools work better. Multi-machine deployments is one of them, for example. In Ansible, there's only one way to run your playbook, Ansible-playbook. But when it comes to NixOS, there are at least 3 actively developed deployment tools, which all have their quirks, upsides, and downsides. A huge part of why Ansible works so well for multi-machine deployments is the ability to access one machine's host variables in another machine's configuration. For instance, I can say find all machines in the group Elasticsearch and get their IPv4 addresses. There are ways to do that on NixOS, but it doesn't have an easily accessible host vars construct like Ansible does, aside from third-party deployment tools. Then there's also the question of long-term stability. NixOS has 2 main versions: stable, which gets a new release twice a year, and the rolling release, which is called unstable. There is no LTS version, and when it comes to stable releases, the previous release becomes end of life almost immediately after the next version comes out. Now, yes, some people are saying that unstable is actually not that unstable, and that it's the best way to use NixOS because you don't get blindsided by a ton of breaking configuration changes every half a year. But at the same time, it is called unstable, so yeah. And then there is the learning curve and the documentation. Ansible is basically just YAML with some Jinja 2 sprinkled in. Nix, however, the programming language used to configure a NixOS system, is an entirely new programming language. Not just that, it's a functional programming language, which means that concepts that you might be familiar with from other languages, like loops, are basically thrown out of the window. Very simple things, like iterating over a list of services or items in a dictionary, sometimes take a lot of mental gymnastics to wrap your head around. Reading some Nix code can sometimes feel like reading a regular expression that was written by somebody else. But despite all of that, I found that for me, NixOS is pretty much the best operating system for my home lab. I don't think I can ever go back to using a non-declarative home server-specific operating system, like Unraid or TrueNAS. And comparing NixOS to those systems is like comparing apples to oranges. You use Unraid or TrueNAS because they're low maintenance, have a relatively easy web UI to configure your system, and don't require programming to configure your services. You use a configuration management tool like Ansible or NixOS because you want to define your infrastructure as code. Web UIs are amazing for ease of use, but the changes you make in a web UI, the mouse clicks you make, the sliders you drag, the options you select, are not easily reproducible or versionable. So some people, like me, find peace of mind in the thought that their configuration is meticulously defined and every change that they've made is tracked in a version control system. It is a complete overkill if your home lab is a practical tool and not a playground for experiments, but I like it. It sparks joy. And NixOS takes everything that I like about Ansible and perfects it. The reproducibility, the integration, the ability to roll back your configuration, the typed language and the fail-fast approach, and the community around it. All of these things is why I run NixOS in my home lab. So that's gonna be it for today's video. I hope you guys enjoyed it, and as usual, I would like to thank my patrons: 3C, 3C1D, Scott Huffman, Christoph Mueller, James Eppington, Carlos Bonilla, David Love, and everyone else supports this channel. Thank you guys for watching, and I'll see you in the next one. Goodbye.